This is a tutorial on how to use the one-way ANOVA or ANOVA single factor in Excel. We use ANOVA or the analysis of variance if we want to compare the means of 3 or more independent groups to determine if there is significant difference among them. This problem is an example of one-way ANOVA or ANOVA single factor. A one-way ANOVA is used when you have one independent variable or the factor with 2 or more levels, and you want to compare the means of those levels on a single dependent variable. So this is the problem. A civil engineer wants to determine whether different types of concrete mixtures significantly affect the compressive strength of concrete after 28 days of curing. There are 3 different concrete mixture types. We have A, B, and C. And the engineer tests 5 samples from each type. So here are the data for the compressive strength after 28 days measured in megapascals. So we have 5 samples for each mixture. We have 5 samples for mixture A, 5 samples for mixture B, 5 samples for mixture C. The question is there a statistically significant difference in the mean compressive strength between the 3 concrete mixtures at the 0.05 significance level? Based from the problem, the independent variable or the IV, so I will write IV for the independent variable, is the concrete mixture. But the concrete mixture has 3 different levels. So we have mixture A, mixture B, and mixture C. And our dependent variable, so that is the dV, is the compressive strength of the concrete mixtures. So based from the definition of the one-way ANOVA, we have one independent variable, but that independent variable has more than 2 levels. And this problem, we have 3 levels, the mixture A, B, and C. And we have one dependent variable, which is the compressive strength. So by this, we can say that we can use the one-way ANOVA or the ANOVA for single factor. So before we perform the test, let's state first the hypothesis. So we have the null hypothesis or the HO and the alternative hypothesis or the H1. So for one-way ANOVA, the null hypothesis will be there is no significant difference among the different mixtures, meaning the sample mean of mixture A is equal to the mean of mixture B and also equal to the mean of mixture C. So we can write the null hypothesis as the compressive strength of A, which is the mixture A, is equal to the compressive strength of B and also equal to the compressive strength of C. Or mean of A is equal to the mean of B and also equal to the mean of C. So take note, the null hypothesis for one-way ANOVA states that the mean compressive strengths for all the 3 concrete mixtures are equal. So they are all the same. So that is the null hypothesis. There is no significant difference. For the alternative hypothesis, we can write that at least one mean is different. So meaning, among the 3 mixtures, there is one that is different. So at least one. Or it is also possible that 2 are different. So Take note, alternative hypothesis for one-way ANOVA, at least one mean is different among the others. So for other references, they use the acronym ALLOY. So meaning A at L least, so at least O is 1, so at least one inequality, meaning not equal. There is a difference. So that is the hypothesis for this problem. So basing from the alternative, this test or the test for the ANOVA factor depend only on one-tailed. So we use the F distribution for ANOVA test, and that is a one-tailed test. So next, we arrange the data or organize the data in a column. So the data that we need here is the different compressive strength for each mixture. So we will just copy these three columns. So we have this column, so at the I column, the data for mixture A, then J column for the mixture B, and for the K column is the mixture C. So each mixture has 5 sample or trials. So next, we do the one-way ANOVA test. So we go to data, click on the data analysis. So here at the start, we can see ANOVA single factor, ANOVA 2 factor with replication, ANOVA 2 factor without replication. So this test is a one-way ANOVA or the ANOVA single factor. So we will click on the ANOVA single factor. Then okay. So for the input range, we need to highlight all of this. So all the data with the labels. Group by, so we will choose the columns because we group the data by column. Then for this one, we need to check labels in first row because we have included the labels. Then for the alpha, so we will not change this because based from the problem, the significance level is 0.05. So this is okay. Then for the output range, so we can choose any blank cell. Then click on OK. So here is the result for the ANOVA single factor. So we can see here the summary and for the ANOVA. So for the summary, we can check for the count. So the count meaning the number of trials or sample per group. So the group is the different mixture. So we have mixture A, mixture B, and mixture C. And each group has 5 samples. So this is correct. For the sum, so this is the total for the compressive strength of the mixture A and with the other mixtures. For the average, so that is the mean. So that is sum divided by the count. So we get the average. And for the variance, that is the sample variance per mixture. So that is the summary of our data. Next is the ANOVA table. So this is the table we need for deciding whether to reject or do not reject the null hypothesis. So for the first column, we have the source of variation between the groups and within the groups. Between the groups meaning mixture A versus mixture B versus mixture C. Within the groups meaning the different samples for each mixture. SS is the sum of squares. DF is the degrees of freedom. MS is the mean square. F is for the F statistic or the F value from the F distribution. Then we have the P value or the probability. Then the F critical. So the critical value for F is based on the alpha. So the sum of squares is computed already by the analysis of variance single factor here in Excel. Then degrees of freedom. So between the groups, the formula for the degrees of freedom is the number of groups minus 1. So we have 3 mixtures, so that is 3 minus 1. For within the groups, that is the total samples, so 5 for each, so that is 15 minus the number of groups. So we have 3, so 15 minus 3. So that will become 12. For the mean square, so that is solved by dividing the sum of squares over degrees of freedom. Then for the F critical, that is mean square between the groups divided by the mean square within the group. So that is the F value. Then P value is from the F distribution also, and for F critical is also from the F distribution. So for our decision, we can use either the F value versus the F critical or the P value versus the alpha. So if we want to use the P value, so if P value is less than the alpha, which is 0.05, we reject the null hypothesis. So let's check. So our P value is 1.11e, so that is times 10 raised to negative 8. So that is smaller than our alpha, meaning we reject the HO. Or we can also use the F critical. So if F value or the F statistics is greater than the F critical, we reject the HO. So take note, if P value, so this one, so if our P value is less than the alpha, so our alpha is 0.05, we reject the HO. And if you want to use the F value or the F stat, if F value is greater than the F critical, we reject the HO. So using the F value, we can see the critical region from the figure of the F distribution. So this is the F distribution. So you can see that it is skewed to the right. So it is not a normal distribution. So here is our F critical, 3.8853. So starting from this one is the critical region. And our F value is 121. So it is at the right part, which is beyond the F critical. So we reject the HO. So our decision is correct based from the result of the test. So our conclusion, there is, because we have rejected the HO, there is a significant difference in the mean compressive strength between the three concrete mixtures at the 0.05 significance level. So this is how we perform a one-way ANOVA in Excel. Now the question is, what group or which mixture is different among the three? So in order to do that, you may use a post hoc test. So you may do a post hoc test to determine which group is different. So under the post hoc test, there are different tests for that. The most common or the widely used is the Saculles HSD or the Saculles honest significant difference, which is widely used for pairwise comparison of group mean after ANOVA. Then there is also the Bonferroni. So it involves adjusting the significance level for each pairwise comparison to control for the overall type 1 error. So you can choose between the two if what post hoc test you want to do to determine which group is different. So take note that you can only do post hoc test if the result from your ANOVA is there is significant difference. But if you have failed to reject the HO, meaning there is no significant difference, you do not need to do post hoc test.